Hey guys, today we're going to be looking at how to find the perimeter and area using coordinates. So we're going to be picking up with that coordinate geometry. Today we're going to go back to where we have concrete coordinate points. So we're not going to do abstract like variables today. But we're going to use these coordinates to calculate perimeter and area of different shapes. So our first question is, given triangle ABC in these given coordinates, can we calculate the perimeter of triangle ABC? Well, let's ask ourselves, what is perimeter? Like, what is perimeter? Perimeter is the distance around a shape. And that definition should cue you in on how we're going to solve this, because it's the distance around the shape. So let's use the distance formula. So to review, our distance formula is written right up here. And we're going to be finding the distance between point A and B, point B and C, and C and A. Those are the three sides of the triangle. If we can calculate the length of each side of the triangle to find the perimeter, we'll just add these three answers together. So let's get into it. Let's find the distance for AB. And I'm using these coordinates up top. Okay? So set up these formulas. Is that we would set up to calculate the distance of AB. 1 minus negative 3 is 4, and 4 squared is 16. 7 minus 3 is 9. Sorry, 7 minus 4 is 3, and 3 squared is 9. Therefore, we have the square root of 25. 16 plus 9 is 25. And we get 5. I'm going to circle that because I know I'm going to be coming back and using that one later. Now we're going to find the length of BC. We have 7 minus 1 squared plus negative 1 minus 7. Sorry, that one's a little sloppy there. Minus 7 squared. Calculating this, we get 7 minus 1 is 6, and 6 squared is 36. Negative 1 minus 7 is negative 8, and negative 8 squared is 64. 36 plus 64 is 100, and the square root of 100 is 10. Now I'm going to circle that because I know I'm going to need that answer when I come back to it. The last side length we got to calculate is the side length that connects vertex C and vertex A. Let's calculate that. We have negative 3 minus 7 squared plus 4 minus negative 1 squared, all inside the radical. Determining this, we would get negative 3 minus 7, that's negative 10, and negative 10 squared is 100. 4 minus negative 1 is 5, and 5 squared is 25. We would get the square root of 125. Now that doesn't have a perfect square, but we can simplify that by taking out or factoring out a 25. Square root of 25 is 5. And we could rewrite this as 5 radical 5. The perimeter would be the sum of these three sides. So we would add them together to be 5 plus 10 plus 5 radical 5, which would equal 15 plus 5 radical 5. Because we combine our like terms. 5 radical 5 is not a like term, so we would leave it just as 15 plus 5 radical 5. Alright? Moving on. We try this cool little formula called Heron's formula. Now, I'll let you guys read on your own, but it is a kind of an interesting formula because it allows us to find the area of a triangle if we only know the side lengths. Typically, if you think about the formula for area of a triangle, it's base times height divided by 2. So I have to know the height of the triangle. In this case, we really don't need to know the height. I can actually just use the side lengths. And like our first example, I know how to figure out side lengths using the distance formula. So the formula itself is area is equal to the square root of S times S minus A. Well, what is this S? S is the semi-perimeter. It means it's half the perimeter. So we calculate the perimeter divided by 2 is the square root of the semi-perimeter times, and it's going to be S minus A, S minus B, S minus C, where A, B, and C represent the side lengths of this triangle. The next page, we're going to do an example of this one together. All right, be patient because this one's going to take us a little bit of time. All right, so I just sketched out a triangle. It doesn't have to look like this. I just did a random sketch of a triangle. But I did this in order to label some sides for you guys. So, we're going to be talking about A, B, and C. I rewrote that formula for you. Think about how we did it with all throughout the year, but maybe with law of sines and stuff like that. We labeled this as side A, side B, and side C. Or we labeled the sides as across from their respective angle. So I'm going to stick with that name when we calculate these side lengths. Okay? So now, when we calculate the side lengths, let's calculate the side lengths of A, B, and C. We're going to need to do that in order to figure out the semi-perimeter as well as these A, B, and C values. A is really segment BC. So I'm going to label this as distance BC. B is really AC right here. So I'm going to put the distance of AC when we calculate that. C is over here. This is segment AB. Now we're going to need to use the distance formula to calculate these three values. All right? The distance formula will look like this. So these are the three distances for our respective side lengths. If you notice for side B and side C, I just rounded to the nearest tenth. And we'll do that for these examples. So side A has a length of 10, side B has a length of 7.6, and side C has a length of 9.5. Again, side B and side C, we did round to nearest tenth. Now, to apply Heron's formula, we need to first calculate the semi-perimeter. That's that S value in our formula. So the semi-perimeter, put it down here, we're going to first take the perimeter. Perimeters add all three sides. The semi-perimeter just means we're going to take half of that perimeter. So we're going to divide the perimeter by 2. Again, we'll round to the nearest tenth, and we get 13.6. Okay? Using that, we get our semi-perimeter is 13.6. Now we can plug all our information into our formula and calculate the area. So our area is 13.6 times 13.6 minus the A value, that's 10. 13.6 minus the B value, that was 7.6. Now I'm running out of room here, but this is all going to be one line, so it's all connected underneath the radical. So this is still times, so it's all one line, 13.6 minus the C value, which is 9.5. So now we're going to calculate this. Now you might want to be using a calculator at this point if you haven't already picked one up by now. But now when we calculate the area, we are going to calculate the square root of 13.6 times 13.6 minus 10 times 13.6 minus 7.6 times 13.6 minus 9.5. We will get the area is about 34.7 square units. All right? The next one, the now you try one example, I'm going to save this one, and like I normally do, we'll throw that post up there in Google Classroom for you guys, so you guys can have that answer there as well. Next, we're going to find the area using the box method. For anyone that doesn't recall, the box method is a way we calculate the area. We're basically going to draw a box that encloses the shape. And we want to draw the smallest possible box to enclose the shape. So, look at this triangle. The way we can enclose the shape is by drawing a box like this. Notice, by creating a box, I'm creating a rectangle. And calculating the area of a rectangle is very simple for us. So now I have this box surrounding this triangle. I can calculate the area of the box. The area of the box is easy, length times width. So it's 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4. So 6 times 4, the area of the box, 24 units. To find the area of our triangle ABC, we would have to subtract or take away the part of the box that I don't want. Namely, I'm going to label this as triangle 1, triangle 2, and triangle 3. I'm going to take away the area of those 3 triangles. Calculating the area of these triangles will be very easy for us too, because if you notice, all 3 triangles are right triangles. And calculating the area of a right triangle is very easy. We don't have to use Heron's formula. All we're going to do is base times height divided by 2. So let's look at the area of triangle 1. We'll put area triangle 1. That's all abbreviated, right? So it's 2 times 1, 2, 3, 4. 2 times 4 divided by 2. Well, 2 times 4 divided by 2. 2 times 4 is 8. Divided by 2 is 4. Area of triangle 2. Notice again, base times height. 1, 2, 3, 4. 1, 2. So I have 4 times 2 divided by 2, also equaling 4. Lastly, I have triangle 3. Again, just to reiterate, these are the triangles that were created from using this box method. I don't want them as my answer. I'm trying to calculate the area of this triangle in here. So I'm going to subtract the parts I don't need. So for triangle 3, it's 1, 2, 1, 2, 3, 4, 5, 6. So that's 2 times 6 divided by 2, which is 6. So my area of the box was 24. The area of the triangles that I'm not going to include were 4, 4, and 6 respectively. So we're going to calculate the area, the triangle of ABC, area ABC. All right, area of triangle ABC, I wrote that backwards, is going to be 24 minus the area of the triangles we don't need. So 24 minus 14 is 20 square units for our triangle. Sorry? That would have been embarrassing, right, as a math teacher? Sorry, 10. 24 minus 14 is 10. So now we get that area is 10 square units. Now, we have to determine the area of other shapes. Think about or recall how we find the area of shapes like a parallelogram. We need to calculate the height and times the base. The base I can count. It's 1, 2, 3, 4. 4 units. The height, man, we want to count the height vertically, so I'm going to use this to calculate my height. Notice I'm not really doing the box method, I'm just counting out the height. So our height is 1, 2, 3, 4, 5, 6 units. So our area is 4 times 6, or 24 square units. Likewise, our right triangle ABC, I don't need to use the box method. I can just count the height and the base. 1, 2, 3. 1, 2, 3, 4, 5, 6. My area is 3 times 6 divided by 2. Leaving my area as 18 divided by 2 is 9 square units. Right. Our last example that we can go over is some other examples using the box method. I'll save A for another post on Google Classroom since we just did a similar triangle. For example B, we're going to again draw a box that encompasses this shape. And we want to make it the smallest box possible that encompasses the shape. I want to find the area of that purple shape there. Meaning I have this area of this box, but I also have this little triangle over here we'll label as triangle 1, and this triangle over here we'll label as triangle 2. I definitely am not going to want to include triangle 1 and 2 in my final area. First, the area of the box. The area of the box is the area of a rectangle. So we're just going to calculate the length and the width. 1, 2, 3, 4, 5, 6, 7. And our height, 1, 2, 3, 4, 5, 6, 7. So my area of the box is 49 units. square units. To calculate the area of that purple figure, I'm going to subtract the part of the box that is not the purple figure, namely triangle 1 and triangle 2. So to find the area of triangle 1, we're going to calculate the base times height. That's 2 times 1, 2, 3, 4. We get an area of 4 for triangle 1. For triangle 2, 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5, 6, 7. 5 times 7 is 35, and 35 divided by 2 is 17 and a half. So to find the area of that purple figure using the box method, we are going to subtract 49 minus 4 plus 17.5. And our final area will be 49 minus 21.5, which simplifies to be 27.5. And we'll put on units squared because we are calculating the area. Alright guys, now take what you learned today and apply it to some of the practice problems on the homework.